This video covers section 8.6 Compound Inequalities, Objective 2, solve compound inequalities involving and. So remember, the last thing we said from Objective 1 is intersections are and, unions are ors. Objective 2, solve compound inequalities involving and. A compound inequality is formed by joining two inequalities with the word and or. For example, 3x plus 1 is greater than 4 and 2x minus 3 is less than 7. 5x minus 2 is less than 13, or 2x minus 5 is greater than 3. These are all compound inequalities. In Objective 2, we will look at how to solve compound inequalities using and. So remember that intersection was where the two overlapped. And when solving these types of problems, look for the overlap of the graphs. So we will look at where these two solution sets overlap each other. The first one, if 3x plus 1 is greater than 4, that says that 3x is greater than 3, or dividing by 3 on both sides, that says where x is greater than 1. 2x minus 3 is less than 7, that says 2x is less than 10, or dividing by 2, that says that x is less than 5. So we're asking the and statement, or intersection, where these two overlap. We have x is greater than 1, and we have where x is less than 5. These two overlap from 1 to 5. Set builder notation. This is the set of all x such that x is greater than 1 and less than 5. Interval notation is just the interval from 1 to 5. And this leads me to practice 3 for you to try. I encourage you to press pause on your video and work this out and come back when you're ready to see the solution. Now that you've had a chance to work this out, I'll work this out with you. We're looking for and, or the intersection. The first one, we subtract 2 from both sides, and we say that 5x is greater than or equal to negative 5. Dividing both sides by 5, we get x is greater than negative 1. If 5x plus 2 is less than 17, then that says that 5x is less than 15, or dividing both sides by 5, we get x is less than 3. So the first set says that x is greater than negative 1. Second set says that x is less than 3. Where these overlap is between negative 1 and 3, and is the overlap, or intersection. So we've got the set of numbers from negative 1 to positive 3. So in set builder notation, we have the set of x such that x is greater than negative 1 and less than 3. In interval notation, we have the set from -1 to +3. So notice how when I wrote the set builder notation, I wrote x is less than 3 and greater than -1. This is a compact way of writing. -1 is less than x, or x is greater than -1, and x is less than 3. So with the and statement, we can write that as a compact inequality. Whereas or, we don't have those same luxuries. So when we have the and statement, we like to write it as a compound inequality. -2x plus 6 is greater than or equal to -2, and -2x plus 6 is less than 14. It's quicker to leave it in the compact form. -2x plus 6 is less than 14 and greater than -2. So instead of subtracting 6 on both sides twice, we do it over here once and subtract 6 from the right side and get 8, and from the left side and get -8. Now we have to divide by the -2, which means we have to flip both of our symbols over and get x is less than 4 and greater than -4. And now we rewrite this the other way with the smaller number on the left and the bigger number on the right. And so now we see it's all the numbers x greater than -4 and I've lost my or equal to here. Greater than -4 and less than or equal to 4. In set builder notation, we have the set of x such that x is greater than -4 and less than or equal to 4. In interval notation, we have from -4 to +4, including 4. And this leads me to practice 4 for you to try. I encourage you to press pause on your video and work this out and come back when you're ready to see the solution. Now that you've had a chance to work this out, I will work this out with you. In the middle, to get rid of the -1, we add 1 to both sides. 11 plus 1 is 12, and 3 plus 1 is 4. We divide both sides by -2. Flipping over the symbols when we divide by a negative number. This gives us x in the middle is less than -2, greater than or equal to -6. And we go ahead and write this the other way. -6 is the smaller number, and -2 is the bigger number. So these are all the numbers bigger than or equal to -6 and smaller than -2. In set builder notation, we say the set of x such that x is greater than or equal to -6 and less than -2. Interval notation is from -6 to -2. In the next video, we will see with ORs, we do not have the same luxuries to write this compact form. We will have to write two separate inequalities. And this concludes the video for section 8.6, compound inequalities. Objective 2, solve compound inequalities involving AND.